Hi there. In this video, I'm gonna show you how to design driver logic circuit in order to show your date of birth on 7 segment. So before starting, if you are new to this channel, please subscribe and press the bell icon for more updates. So let's begin. First, we'll discuss designing criteria for this circuit. So we have 3-bit input and 7-bit output. By 3 input, we know it means we have 8 different input combination for our design. Now as the input counts from 000 to 111, we can use these input for displaying date of birth on 7 segment display. We'll use common cathode 7 segment display for this design. Date of birth will be displayed in mm-dd-yy format. Consider the following date of birth as an example, which is 3rd day of February in 2001. You can design the circuit for your own date of birth by following the step as I did. Our next step is to fill truth table for the by following designing criteria. So before doing that, I want to tell you how to display any decimal on 7 segment. As we know, we have only 8 input combination for 3-bit inputs, so we can show only 0 to 7 decimal on 7 segment display. In 7 segment, we have 3-bit input, which is the output of our design, where A bit is as MSB and G bit as LSB. So how to display any decimal? Let's take an example of decimal 7. So in order to display 7 on 7 segment, what will I do? I'll give low logic to bit F, bit G, bit E and bit D, and I'll give high logic to bit A, bit B and bit C. So the resulting input for 7 segment will be 1 1 1 0 0 0 and 0. This figure after displaying 7 and 7 segment, this 7 segment will look like this. Now by applying this logic, I filled the truth table for our design. Now start making K map for all outputs. Now start grouping of number of ones for this output. This will be the first group. Now look for changing output bit in this group. The changing output bit for this group is Z. So the resulting logic for this group will be X complement Y complement. Now this will be the second group. Now look for changing bit again. In this group, which is bit Y. So the resulting logic for this group will be X complement Z. Now this is the last group for the K map for A. Now look for changing output bit in this group, which is changing output bit for this group, which is Y. So the resulting logic for this group will be X Z complement. Now K map for P. Now start making group of ones for this output. This will be the first group, and now look for changing bit in this group. Changing bit in this group is Z, so the result is X complement Y complement. This will be the second group, and now look for changing bit in this group, and changing bit in this group is X, so the result for this group will be YZ. This will be the last group in this for K map of P. Now look for changing bit in this group. Changing bit in this group is Y, so the result is XZ complement. Now K map for C. Now start making group of ones again for this output. This will be the first group, and changing bit in this group is X, so the result is Y complement Z complement. This will be the second group for this K map, where changing bit in this group is X again. The result is YZ. This is the last group for this K map, where changing bit in this group is Y, so the result is XZ complement. Now K map for D. This will be the first group, and the changing bit in this group is Z, so the result is X complement Y complement. This will be the second group. In this group, the changing bit is Y, so the result is x complement z. So this is the x complement z. Now this is the last group for K map of T, where changing bit is y, so the result is xz complement. Now K map for E. This will be the first group for this K map, where changing bit in this group is changing a bit for this group is z, so the result is x complement y complement. This will be the second group, where changing bit in this group is y, so x complement z, as it is mentioned here. Now this is the last one, which is we cannot make any group for this one, so the result is x y z complement. Now K map for F. This no group can be make, we cannot make any group for this K map, so we all simply use logic for this K map, where x complement for x complement y complement z complement for this one, x complement y z for this one, and for this one x z x y and z complement. Now for our last output G, K map for G, we can make this will be the first group, where changing bit is y, and the resulting logic for this group is y complement z, and y complement z. This will be the second group, and the changing bit in this group is z, so y x and y complement. So this is as mentioned here. Now this group, this one cannot be grouped by any other one, so we will write it down as individually. So the result for this one will be x complement y and z. Now I have already implemented this logic in Multisim, and now I'll check the result of my design. Now this is the circuit for this is the circuit as we have designed. Now I start simulation and put all inputs to check to verify our design. So by first 0 0 0 output must be 0. Now 0 0 1 output must be 2. Now for 0 1 0 output must be dash. Now for 0 1 1 output must be 0. Now for input 1 0 0 output must be 3. Now for input 1 0 1 output must be dash. Now for input 1 0 1 1 1 0 output must be 0, and for the last input 1 1 1 output must be 1. So in this video we learned how to design a logic circuit for display in order to show your date of birth in 7th segment. I always like reviews on my videos, so please give your reviews for this video in comment section. Thank you.